It's time for lesson 3 in our unit on multiplying and dividing fractions. Today's learning target is that you will be able to say, I can multiply a whole number by a fraction and get a fraction as a product. And I know you're thinking to yourself, wait a minute, Mrs. Rose, we've been multiplying whole numbers and fractions for the past 2 lessons, so how is this any different? Well, the difference is the last part of the sentence here that says, I will get a fraction as a product. All of the examples that we've been doing so far have produced a whole number as the product. Take, for example, this problem, 1/4 of 24. You know that that would be the same as saying 1/4 times 24 over 1, which would give you 24/4, and that's equal to 6. So our product of these two factors was a whole number that is greater than the fraction, but less than the whole number factor. And if we made that 3/4 of 24, we would still end up with a whole number as the product, because we know that 3/4 of 24 would be 6 plus 6 plus 6, which would be 18. 6 plus 6 plus 6, because we would have 1/4 and 1/4 and 1/4. So if 1/4 of 24 is 6, then 3/4 would be 3 times 6, which would give us 18. And again, the product is greater than the fraction, but less than the whole number. We will be getting into some shortcuts for how to solve this problem, or a problem like it, without having to go through all of this in our minds, but that's going to come a little bit later. For now, what I want you to pay attention to is anytime we've multiplied a fraction by a whole number, the result has always been another whole number. When we look at these problems, we can see the same result, that we end up with the whole number as the product. But the question is why? It happened because the whole number could be evenly divided by the denominator every time. So 15 could be evenly divided by 3. We get 5, so 1/3 was 5, and the other third was 5 more. When we divide 21 by 7, we find out that 1/7 was 3, so 3/7 made 9. When we divided 32 by 8, we found that 1/8 of 32 was 4, so 2/8 would be 4 more, or 4 times 2. 4 plus 4, 4 times 2. So we will always end up with a whole number as the product as long as the whole number factor can be evenly divided by the denominator of the fraction. Now look closely at these two problems. Do you notice anything different about these examples than the ones we just looked at before? Pause for a second and see if you can see the difference. You should have noticed that when you looked at the whole number factor and then compared it to the divisor of the fraction factor, that the whole number in both cases cannot be evenly divided by that denominator. 8 cannot be evenly divided by 3. 6 cannot be evenly divided by 5. Because of that, what's going to end up happening is that we are going to end up with a mixed number or a fraction as our final product. And if we solve that through the way we've learned, we can see that it's 1/3, oops, sorry about that, 1/3 times 8 over 1, which leaves us with 8/3. And you learned in our first unit that when you have 8/3, that's a fraction greater than 1, or improper fraction. So we can leave it as the fraction or turn it into a mixed number, which would be 2 and 2/3. 3 goes into 8 2 times, with a remainder of 2 for our numerator here, and the number stays 3. And the problem below, 2/5 times 6/1, it's the same thing, leaves us with 12/5. And again, we could leave this answer as a fraction, or fraction greater than 1, or we could turn it into a mixed number. 5 goes into 12 2 times, with a remainder of 2, and the denominator would be 5. I'd like you to notice something else about the final products in both of these problems. The first thing I want you to notice is that, as we said, they ended up as mixed numbers. But that won't always be the case. They may end up as fractions that are less than 1. These are fractions greater than 1 that become mixed numbers. But sometimes your product will be a fraction that is actually less than 1, where the numerator is smaller than the denominator. But nonetheless, these two problems do still follow our rule of multiplication with fractions and whole numbers. The product is greater than the fraction factor, but less than the whole number factor. 2 and 2/5 is greater than 2/5, but less than 6. Now let's look at an example of a problem where the final product will be a fraction, but a fraction less than 1, so not a mixed number. An example of that might be 2/7 times 3. Well, that is 2/7 times 3/1, and that leaves us with only 6/7. 6/7 is not an improper fraction. It's not a fraction greater than 1 because the numerator is less than the denominator. So even though we multiplied, we ended up with a fractional answer, a fraction that was less than 1. But it does still follow our rule. The product, 6/7, is still greater than the original fraction factor of 2/7, and it is still less than the whole number 3 that it was multiplied by. So even though we got a fraction as our answer, it was still greater than the fraction factor, but less than the whole number. I want you to stop your video now and go ahead and try these sample problems. When you get the product, if the product is a fraction greater than 1, please turn it into a mixed number. If the fraction is not a fraction greater than 1, you can then just leave it be. Pause now. Right now, I bet you're thinking, that was a piece of cake, and you're feeling really cool. But let's just double check your work. When you went through and you solved the problems, you can see that 1 times 4 gave me 4, and I now multiply the denominators, which gave me 5. That was the final product because that fraction was not a fraction greater than 1. Here I multiplied 2 and 7, and I got 14. Multiply the denominators. 3 times 1 gave me 3. That gave me 14/3. 14/3 is a fraction greater than 1, so it gets turned into the mixed number 4 and 2/3. And finally, 3 times 8, the numerators in the last problem, gave me 24, and 5 and 1 gave me the denominator of 5 when I multiplied. 24/5 was also a fraction greater than 1, so I had to rewrite it as the mixed number 4 and 4/5. Now, there's another way I can think of these problems when I'm solving them that won't require me to write the whole number as a fraction greater than 1, where the whole number is simply on top of 1. What I can think of instead is simply saying that this would be the same as saying 1 times 4/5. I still end up with 4/5. And this problem is the same as saying 2 times 7 over 3. I still end up with 14/3. It's just kind of a shortcut. And again, final shortcut here, we could say that this problem, rather than rewriting it completely this way, would be the same as 3 times 8 over 5, 24/5. It doesn't change anything, it just cuts out somewhat of a small step. So now I know that you know how to solve a problem like the one above, but now we're going to look at how we can picture a problem like the one above. And we're going to do that using two different kinds of models. One of them is a rectangle area model, and the other is a number line. When we are trying to represent this kind of a problem on a number line, we imagine the number line across. And the number line will have 3 holes represented on it, because there are 3 holes in the problem. Each hole will be divided into fifths, because 5 is the denominator of the factor in the problem. So I divide this one into 5 equal pieces by making 4 lines. I'll do the same here. And now there are 3 holes, and each hole is split into 5 pieces, or fifths. To show that on the number line, all I have to do is circle the 2/5 in each hole, because this does say 2/5 of 3. So if I circle 2/5 in this hole, and 2/5 in this hole, and 2/5 in that hole, I have a total of 6/5. So the number line, the line was divided into 3 pieces to represent the 3 holes. Each hole was split into fifths because of the denominator in our fraction. And then I circled 2 in each. And so now there are a total of 6 circled fifths on the number line. But another way to show this is to use what we call an area model. And those are a little bit different. In an area model, we want to have a rectangle to start with. And the rectangle, like the number line, starts off by getting divided into the same number of pieces as the whole number in the problem. In this case, we're talking about the same number of columns, or columns total. So 3 columns total, 1 for each hole. And just like we separated the number line into fifths for each hole, we're going to do that here. So I have 5/5 being made in each hole. So there are 3 holes, and each hole has 5 pieces. Now in the number line, we circled each fifth. Here we're going to shade them in. So I shade 2/5 in the first hole, and 2/5 in the second hole, and 2/5 in the third hole. And so I have 6/5, just like I did on the number line, and just as I get as the product when I multiply. It's your turn again. So I would like you to solve these 2 multiplication problems, show your answers, and then also draw 2 models for each. Please try to draw a number line model and an area model. Just do the best you can, and remember, I'm going to go over it with you when you're finished. Pause now and try. So we're going to now take this number line And if this is the end of the number line, and here's the other end, I need to divide this number line into 4 holes. 4 holes because there are 4 holes represented in the problem. 4 is a factor. Then each of these needs to be divided into 6 pieces because 6 is the denominator in the other factor. So I do that. And of course, I only need to put 5 lines in to make 6 pieces. 1, 2, 3, 4, 5, and 6. So when you need to make 6 pieces, you only need to make 5 cuts. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Now I just have to circle 1/6 in each hole. And so that's a total of 4/6. On the area model, you would have divided it into 4 columns for each hole, and then you would have split each column into 6 pieces. So 2, 4, 5, and 6. And now there are 6 pieces in each. And we need to shade 1/6 in each hole. And there again is 4/6. And we solve that out. We know it is 1/6 times 4 over 1, or simply 1 times 4 over 6 makes 4/6. On the bottom example, we take our number line again, and we need to section it off to show the whole number factor. So this is the end of each side of the number line. I'm going to make 5 holes out of it. So again, if I'm making 5 pieces, I need to cut the line 4 times. 1, 2, 3, and 4. And now I have 5 pieces or 5 holes on the number line. And I'm going to divide the number line into, or the pieces of the number line, into 4ths. So I make 3 cuts to make 4ths. 1, 2, 3, and now there are 4 pieces. 1, 2, 3, and there's 4 pieces between here and here. And 1, 2, 3, 1, 2, 3, 1, 2, and 3. And now each hole on the number line has 4 pieces in it for the 4ths. I circle 3 in each. There they are. And then I have 3, 6, 9, 12, 15 fourths. And to do that on the area model, I divide it into 5 columns. Again, 4 cuts to make 5 columns. 1, 2, 3, and 4. Now I have 5 holes represented. And if I'm going to now represent the 3/4, I have to cut each hole into 4 pieces. So I go across, 1, 2, 3 cuts makes 4 pieces, and we shade in 1, 2, 3 in the first hole, 1, 2, 3 in the second, 1, 2, 3 in the third, the fourth, and the fifth, and now there are 15 fourths being shaded in. We solve that out. 3 over 4 times 5 over 1, or simply 3 times 5 over 4, and that is 15 fourths. And we can rewrite that as a mixed number. And in this case, 4 goes into 15 3 times, and 3/4 are left. Looking forward to seeing you all in class tomorrow.